Have you ever looked at a cloud and wondered about its origins? It's not just evaporation at work. There's a hidden living connection between the ocean and the sky. A surprising number of clouds over the open sea owe their existence to the tiniest ocean life. Phytoplankton. These microscopic organisms, drifting in sunlit waters, are the foundation of the marine food web. When they live and die, they release a special gas that escapes the ocean and rises into the sky. There, it transforms and becomes a key ingredient for cloud formation. This process shows how the ocean and atmosphere are in constant, dynamic exchange. Even a simple cloud is the result of complex, interconnected systems. The air we breathe and the climate we experience are shaped by these invisible oceanic processes. To truly understand our planet, we must see the delicate threads connecting all life and matter. To grasp this connection, let's dive into the world of phytoplankton, the ocean's invisible forests. Through photosynthesis, they absorb carbon dioxide and release oxygen, producing over half the oxygen in our atmosphere. Every other breath you take is thanks to these tiny drifters. Phytoplankton come in many forms: glassy diatoms, armored coccolithophores, and agile dinoflagellates. Their lives are shaped by sunlight, nutrients, and constant threats from predators and viruses. To survive, many produce a chemical called DMSP, which helps them cope with stress. When phytoplankton are eaten or decompose, DMSP breaks down into dimethyl sulfide, or DMS. DMS is the source of the ocean's distinctive scent, the smell of life at work. This gas doesn't stay in the water, it rises into the atmosphere. There it begins a journey that will ultimately help form clouds. The fate of the sky is tied to the struggles of these microscopic ocean dwellers. Their chemical defenses become the seeds of clouds. The story of a cloud begins with the life and death of plankton. Dimethyl sulfide, or DMS, escapes the ocean and enters the atmosphere, especially where phytoplankton thrive. Over remote oceans, DMS is a major source of atmospheric particles. Once airborne, DMS undergoes chemical reactions, transforming into sulfate aerosols, tiny, invisible particles. These aerosols can remain suspended for days, carried by winds across the globe. Over land, dust and pollution dominate, but over clean ocean air, these biological aerosols take center stage. They form a fine haze that changes the air's properties. Each year, millions of tons of sulfur are released this way, shaping our atmosphere and climate. This is a living dialogue between ocean life and the sky. The chemistry of our air is deeply linked to the life in our seas. Clouds need two things: water vapor and a seed to form around. Water vapor is plentiful above the ocean, but it needs a tiny particle, called a cloud condensation nucleus, to condense into droplets. Sulfate aerosols from phytoplankton DMS are perfect seeds. In clean ocean air, these biological particles are often the main source of cloud seeds. The number of these seeds affects the type of cloud that forms. Few seeds mean larger droplets and rainier, darker clouds. Many seeds mean more, smaller droplets, making clouds brighter and more reflective. A bloom of plankton can lead to brighter clouds above. This isn't just a curiosity, it's a process that can influence Earth's climate. The journey from plankton to cloud is a powerful natural cycle. Clouds are both a blanket and a sunshade for Earth. They trap heat at night but also reflect sunlight back into space during the day. Low, thick clouds over the ocean, shaped by phytoplankton aerosols, are especially good at cooling the planet. When plankton blooms release more DMS, more cloud seeds form, creating brighter, more reflective clouds. This increases Earth's albedo, reducing the amount of solar energy absorbed. It's a natural feedback loop. More plankton, more cooling clouds. The health of ocean life directly impacts the planet's energy balance. Changes in plankton populations can shift the brightness of clouds and influence global temperatures. The smallest ocean creatures help regulate the largest planetary processes. Our climate's stability depends on this delicate system. In the 1980s, scientists proposed the claw hypothesis that the plankton-cloud connection could act as a planetary thermostat. The idea was that warming would boost plankton, leading to more DMS, more clouds, and a cooling effect, a self-regulating system. But reality is more complex. Warming can sometimes reduce plankton by limiting nutrients, and not all species produce DMS equally. The feedback loop exists. But it's not as strong or simple as first imagined. The system is nuanced, influenced by many factors, and more fragile than once thought. Still, the link between ocean life and climate remains vital. For years, studying this connection globally was nearly impossible, until satellites changed everything. From space, we can track phytoplankton blooms and cloud properties across the entire planet. Ocean color sensors reveal where plankton thrive, while other satellites measure cloud brightness and droplet size. By comparing these maps, scientists have confirmed that clouds above rich plankton blooms are brighter and denser. This satellite view has revolutionized our understanding, proving the global scale of the ocean-sky connection. The dance between biology, chemistry, and physics is now visible from space. Satellites have unveiled a hidden world of connection, right above our heads. The story of clouds is written in the language of life. This ancient cycle is now under threat from human activity. Warming and acidifying oceans are changing the makeup of phytoplankton communities. If DMS-producing species decline, fewer cloud seeds will form, leading to darker, less reflective clouds, and more warming. Pollution and nutrient runoff disrupt the balance, causing harmful blooms and damaging marine life. The fate of clouds is tied to the fate of plankton. Our actions ripple through the ocean and into the sky. Protecting the ocean isn't just about marine life. It's about preserving the systems that sustain our climate. The health of the sea shapes the air we breathe and the world we know. We must recognize and protect these vital connections. By sharing this knowledge, we can inspire action to safeguard our planet's future. If you found this video insightful, please like and share it with others. Don't forget to subscribe to our channel for more fascinating stories about our planet and the science that connects us all.